Agency, living and artificial agents. Agency in this context is the ability to act and to be a source of behavior. And I will first address living agents. So the key point of a living agent is cognitivity. And cognitivity is defined as follows. A system is cognitive when its behavior is governed by the norms of the system's own continued existence and flourishing. So cognitivity is about surviving, coping with problems, problem solving, that is the existent, continued existence part, and flourishing. And flourishing is about thriving, it's about co-creating, and it's about pervasive optimization. So the optimization of everything in the context of everything else in your life and in your environment. And agency is the key aspect of this. A living agent is an autonomous system that adaptively regulates its coupling with its environment and contributes to sustaining itself as a consequence. So let's see why adaptively regulating its coupling is so important. Well, this is my depiction of a general system. This is the system, it is part, it has all kinds of subsystems, and all those subsystems are related, and all the internal relations are stronger than the external relations. So that makes this a system worth defining. In its environment there are all kinds of other subsystems that are also connected in one big mesh, and but they do not really have that property of that they have internal relations that are stronger than external relations. So if we want to make this into an agent, we have to bring the input and output of the system under the system's own control. So this here is control over the way it interacts with this subsystem on the outside, and this is how it influences the input coming from this part of the environment. And so we have all the inputs and outputs of the system under the control of the system itself, and that not yet makes something a living system. It becomes a living system when those processes that are going on leads to self-sustenance, so that the system is itself responsible for its own continuation, and then we have a living system, a living agent. Another way of showing that is here we have an agent, and an agent is coupled to its environment, and it is very important for an agent to remain viable itself, of course, but it's also important that it is in an environment that is as viable as possible and that provides whatever it needs. So it needs to keep itself alive and viable, but it also needs to contribute to the environment so that the environment also remains of high quality. And an agent that does that is a thriving agent. An agent that is struggling to remain viable is a struggling agent with low viability. And now the key point of agency is that the input and the output is under control of the agent. So the agent can determine what it will do and to what degree it interacts with its environment, and how it perceives its environment. And how it perceives its environment is typically in the form of affordances. The environment offers all kinds of behavioral opportunities. If you observe those behavioral opportunities, affordances, then you have all kinds of options, and eventually that leads to the selection of a certain type of behavior, certain type of interaction, and that you execute in the way you see fit and at that moment, and that leads to a certain interaction with the environment, and hopefully that leads net to the maintenance or the growth of a high quality environment. So, but of course you need to eat, but you cannot eat only. You have to contribute also something so that the environment keeps on giving whatever you need. So here we have the adaptive regulation of the coupling again. So that is depicted like this. This is a more parsimonious way of saying pretty much the same. We have our agent, it is working on its own viability, and we have the habitat that is typically an open environment, and here the agent is bringing its interactions with the habitat under its own control. And the agent can be protecting its own viability, and then it's coping, but it can also be contributing to high environmental quality, and then it is co-creating. Life is all about avoiding death in the service of co-creating high viability habitat. And it does so by balancing both asserting yourself in the environment, so having an influence on the environment, which is typically energy intensive, but also adapting to the environment, which is generally more energy efficient. And at the same time, the environment offers affordances and all kinds of constraints. Constraints like dangers, for example, that entail that you cannot do certain things and that you have to be very careful not to make the wrong mistakes, to act in the wrong way. So this is all related to what I call core cognition, and that is a topic for a fair part of the System View on Life course. But core cognition is about avoiding death and avoiding unpleasant and unviable situations and working towards pleasant and viable situations. This is the viability axis. This is far from death. So this is where you want to be. A thriving agent is here. A struggling agent is here. In a thriving environment where you don't have to do so much, where the environment is uneventful and you can be deactivated, is an environment with few constraints. But you can also be active in an environment, and that is typically when you have many options or many affordances. In a difficult situation, then you have many constraints, so not all behaviors are allowed, or many behaviors are dangerous. So you're close to death in that sense, and you have to watch out really well. So this is the danger situation. And here you have a situation in which you have very few options, where it is very difficult to actually find whatever you need. Yeah, so this is a deficient environment. So this is what I call core cognition, and this is kind of the problem that all living agents have to solve. They have to remain as much as possible far from death, so in this environment. But at some points in time they will be brought here, and then it's their task to go to the right side as quickly as possible. Now we can define different levels of agency, and throughout evolution, agency has increased in a particular way. And basically, agents early on in evolution, and still many bacteria, and so they are strongly locked to their environment via perception, action, contingencies. So if they perceive something, they act in a particular way. Yeah, and that is in a direct loop, kind of. So, and that means that the environment is mostly in control. Yeah, so the environment kind of decides what the agent does. But if the agent has more choices of behavior, and it can simulate in its mind a number of things and then choose the best option, then the agent becomes a little bit more in control of its own environment. And if it is also able to create something like a meta perspective in which it can do reflective reasoning, and it can plan its actions out, and it can simulate all kinds of different behaviors, then the agent becomes more and more control of its own life, and also more in control of its environment. Yeah, so we have different levels of agency here. And this is again associated with the cognitivity. Yeah, so a system is cognitive when its behavior is governed by the norm of the system's own continued existence and flourishing. Yeah, so the flourishing part is typically associated with being able to do this really well. Another thing, more practical and associated with what artificial agents do, is what you could call the agent loop. So here we have a loop that in 6 steps, kind of, in which a small part is outside the agent and a big part is inside the agent. And it works more or less like this. You have a situation, that situation leads to data that is transferred into information that is made into knowledge. The knowledge is used for planning, and the planning is used for actions, and the actions then influence the situation that lead to a new set of data and to more information, etc. So this loop continues. And there are all kinds of words associated with the different steps that we know that make sense from a cognitive science point of view, and also from an artificial intelligence point of view. The main thing is that any agent, also artificial agents, need to be in sync with the environment. So they need to know something about the situation, and their knowledge state of the situation they are in needs to be matching the actual situation. And you can call that synchrony. When the knowledge state of the agent is in synchrony with the situation, then the agent has a chance of doing the proper thing. When it's out of sync, it has no chance of selecting the proper behavior. The step between the situation and data, you can call that transduction. That is the transduction from physical energy into neural energy. And then the neural system transforms the information that comes in via pattern detection, and the patterns then lead to information. And the information can then lead to a certain classification. I see this and this. And that leads to categorizations of the type, I am in this type of situation, which is associated with knowledge. And on the knowledge you can then reason. And the reasoning leads to consequences, and via planning to choices. And then the choices need to be prepared into actions that are at a certain moment executed. And that then leads to a change of the situation, etc. And it allows us to go through the whole loop again and again. And there is a very special moment here, and that is this part here. That is the action initiation. And for a living agent, it means that the living agent has faith in itself and the environment, that it can deal with the consequences of its own actions. And that is a really important thing. Yeah. That is the reason why we stop sometimes and really think well before we engage in a certain behavior. So you could say that living agents always promote viability of self in the habitat, and that basically entails that the purpose of life is to produce more life, because promoting viability of self and the habitat always leads to more life. So that is a key point of living agents. So let's now go to simple artificial agents. And a very simple artificial agent looks more or less like this. So we have the agent. The agent has sensors. That sensors tell it something about the state of the world, and it has actuators, say a robot arm or something like that, and then it can influence the world. By the way, this artificial agent can also be a software agent, for example. It doesn't have to be a robot. The important thing is that, and we said that before in the lecture on closing the system, that the user has to ensure that the system that they are using are exposed to the information that it can actually deal with. So I usually draw a line around this that basically indicates that this can only function in a user-controlled environment. So let's look at a number of agent features. Well, these are the features of a general cognitive system. And here in this picture, the agent and the environment are both present. It has actions, it has past experiences, that's a part of its knowledge. It makes observations, that is somewhere in here. And it has goals and preferences that go somewhere here. And it has certain abilities, stuff that it has learned. Yeah, so this kind of fits with the general agent perspective, the living agent perspective. So let's go now to a very simple agent, a reflex agent. So that is an agent that lives in an environment, or is in contact with an environment. Here we have the agent. It has, via sensors, some idea of what the world is right now. And then it has to create actions, and those actions are informed by condition action rules. Basically, if this is the case, then we do that. And so the state of the world is combined with its rules, and that determines what actions it can do, and then the actions are automatically activated, and it interacts with its environment. Well, this is a system of very little intelligence, and it is pretty close to a very simple agent with perception, a living agent with simple perception action contingencies. It can only respond to the immediate now, only concurrent sensor data, and in principle the condition action rules, they explode very quickly if the environment is not very simple. When the environment is super simple, then this is manageable. If the environment is a little bit more realistic, then this explodes. And especially if the environment changes, then basically you have to change this. So this is a very basic agent. It works in some situations, but only in pretty simple situations. But we can improve this agent. And then we get, for example, a model-based reflex agent, which is basically the same. This and this part is still the same. It still needs to be in synchrony. But now it can kind of remember in what state of the world it was in the previous time step, or maybe in many time steps ago. So it has an idea of its past. And therefore it can develop an idea of how the world evolves, and it can also develop an idea of, if I do certain things in the world, what would be the consequences. And yeah, so it can then use all these things to come with the if-then action rules, combine them with the state of the world, or with the desired states of the world, and that leads to an action of what I should do now. Yeah, so generally, if you have more knowledge about how the world actually works, it is easier to make a set of if-then rules. We can also make the agent a little bit more complicated and give it a particular goal. Same agent, yeah, so it's still in contact via its sensors, and it has an idea of what the world is now, again via a state of the world, how the world evolves, what my actions can do. But here there is a planning phase. So what will it be like, the world be, if I do action A or action B or action C or whatever. Yeah, and then it has a number of different things, and it can simply say which actions realizes my goal best. Yeah, my goals the best. And that it will do that then, and it will interact with its environment and come back, etc. So if the goal is going to a particular place, then all the actions will be evaluated of how well it approaches that particular place. Yeah. And maybe it has multiple goals, and then it becomes more difficult. But generally this minimizes a cost function. Yeah, so a distance tool, for example. Then we can go to the last model that we do today, a utility-based agent. And utility-based agent, same general structures. What is the world like now? Must be in synchrony with the environment. And it has its tools to figure out how the world develops. It has the tools to figure out what my actions will be. But now it has another step, and that is called utility. And it tries to maximize its own utility or happiness, or anyway, a function that says how far it is from death, basically. So it's a viability function, and it can be a complicated, multidimensional utility or viability function. Yeah, so it might at the same time be worried about how much energy it currently has and how well it is able to realize its state, and if it will be able to return to home before its energy runs out, etc. All those kind of things can be part of a utility function. So that utility function is then maximized always, and that leads eventually to more proper behavior and a more effective agent. So you see that this agent is already coming closer to the ideal of, or the ideal to do more complicated agents. So it has something like data, it has some information, it detects patterns of, for example, of what state the world is in. It has a certain knowledge, it can do planning and execute action. So it is kind of coming in a direction of this loop, but there are a number of important differences. This agent, however complicated it is, doesn't care about its own existence at all. So it is not a living agent, it is an artificial agent that does simply whatever it does, but couldn't care less whether it would do something else. So what do artificial agents? Well, they basically execute a task defined by the designer, and their purpose in life is to execute that task. So now we have living agents that promote viability of self and the habitat, and the purpose of life is to produce more life. While artificial agents execute a task defined by a designer, and their purpose is to execute that task. So we are talking about two quite different things and different purposes. So that is interesting.